Yes, good afternoon, everyone. Fine. So yesterday we have started with a new chapter, that is solutions. Okay, so what all things we have seen? So just we'll revise. So we have seen the terms. Okay, we have seen what is solution, right? Then we had discussed about what is a homogeneous mixture. Then we had discussed some of the terms like solute, solvent. Okay, then we had discussed something called as binary solutions. Okay, so what are binary solutions? Binary solutions consist of two components. It is made up of binary, means two components. It is made up of two components. Okay, so the solutions which consist of two components are called as binary solution. So we know how the solution is made up of, right? The solution is made up of solute and solvent. So solute will be present in smaller quantity and solvent will be present in larger quantity, right? So the solvent, okay, the solvent will decide the physical state of the solution. So depending on this, we have discussed the type of solution. Okay, we have discussed the type of solution. So these binary solutions, they are classified as three types. So gaseous solutions, liquid solutions, and solid solutions, right? So we have discussed these. Okay, what type of solute, what type of solvent, depending on these, we have discussed the examples also, right? So these all things we have discussed in our previous class. Then we as you all know, we are mainly focusing here in this chapter on liquid solutions. Okay, we are only going to focus on liquid solutions. So for our understanding, we had also seen what are gaseous solution. So as you all know, the solvent will decide the physical state. So the solvent should be a gas. When you want a gaseous solution, your solvent should be a gas. So a small amount of one gas is dissolved in a larger amount of gas. So both the solute and the solvent should be a gas. Okay. So example, we have seen air. Okay, air. So you know, air consists of different types of molecule. Okay, like atoms, like nitrogen. So the main component in the air is nitrogen, which is 78% oxygen, and some of the other gases are also involved. Okay, so this was an example of a gaseous. Then we had started with the important thing, that is different methods. Okay, how do we how do we calculate, or how do we what you say, define, okay, the concentration of solution. So depending upon the composition of solution, so in terms of what concentration, so these were the different terms. So we had discussed some of the terms like mass percentage, volume percentage. Then we had discussed mass by volume percentage and ppm. Okay, so now I want you all okay, answer from you. What is mass percentage? Can you all define what is mass percentage, students? Yesterday, okay, all had told, they have understood. So now I want the answers from you all. Did you, how well you have understood? Let me see. Yes. What is mass percentage? The formula is given here, right? Just you have to define it now. So I had told you the definition also. What do you mean by mass percentage? What is mass percentage? How much amount of solute? Okay, how much amount of solute? So mass is always expressed in terms of grams. Okay, gram is the smallest unit. So amount of solute in grams. Okay, dissolved in 100 ml of solution. Okay, in 100 grams of solution, because we have taken total mass of solution. Okay, we have taken total mass of solution. So the amount of solute in grams present in 100 grams of solution. So this is the mass percentage. Next is volume percentage. Okay, we had seen about volume percentage. Anybody would like to tell what is ppm? Definition of ppm. What is ppm? Parts per million. Okay, so how do you define parts per million? Okay, how do you define the parts per million? Parts per million is what? Number of parts of solute, okay, present in million parts of solution. So this is parts per million. Okay. Now, next is mole fraction. Next is what? Mole fraction. So in the previous, yes, Anita has, yes, now she has replied it for mass percentage. Yes, good. Okay. So fine. So in the previous session, we have seen four important concentration terms. Okay, that is mass percentage, volume percentage, mass by volume percentage, and ppm. So now we are left with these three, that is mole fraction, molarity, and molality. So based on the four terms, we have also seen how do we express the, okay, so we have seen the examples also. So now we are going to start with mole fraction. Okay, mole fraction. What do you mean by mole fraction, students? Yes. How do so it is denoted by psi. Okay, like this. So like x. So this is a like x small x. Okay. So mole fraction of a component is given as moles of solute. Okay, moles of solute divided by, okay, total number of moles of all the component. Okay, so this is your mole fraction. So if we have to write it mathematically, okay, it will be xa equals to chi a equals to, okay, na plus nb. That is, if you are finding the mole of a particular solute, okay, so this is a solute, right? So if you are finding a that is number of moles, that is a mole fraction of a component of a particular component, so you have to take the moles of that component to the total number of moles present. Okay, so that is your mole fraction. So this is the mole fraction. This is the mole fraction. So how do we define this? Ratio of, we are taking the ratio. So ratio of number of moles of one component to the total number of moles of all the components. So this is your mole fraction. Okay, ratio of number of moles of one component to the total number of moles of all the components. So this is your mole fraction. Understood? Is it clear? So whenever we are finding the mole fraction of a particular component, so we are going to take the mole fraction of that component to the total number of components. Okay. So suppose there are components A and B. So the ratio, okay, so it should be equal to always 1. It should be equal to always 1. Okay, let me repeat it. So mole fraction, what do you mean by mole fraction? Whenever you are calculating the mole fraction, okay, so of a particular component, we are going to consider the number of moles of a particular component. Okay, that is of a particular solution. Suppose there are components A and B. Okay, there are components A and B. So this the ratio should be always equal to 1. Okay, suppose there are Na plus Nb plus Nc. How much ever the components should be, it should be, the ratio should be always equal to 1. Now, if I consider the above, okay, that is Na plus Nb equals to 1. So here, so if I want to find the number of mole, that is a mole fraction of Na. If I want to find out the mole fraction of that is A, component A, then how do you find? So number of moles of A divided by how many total moles are there? So it is Na plus Nb. Now, if I want to find the mole fraction of B, how do I write it? It will be, okay, mole fraction of B equals to Nb by Na plus Nb. Is it clear? So it is the ratio of number of moles. Okay, it is a ratio of number of moles of one component. Is it a one component? Yes, to the total number of moles of all the components. Fine. So this is the mole fraction. Okay. Now we'll discuss one example on mole fraction. So if we consider a binary mixture, so as you know, so always the when we are considering a binary mixture, now binary mixture is made up of how many components, students? Binary mixture is made up of two components, right? Because binary means two components. So whenever we are considering a binary solution, there should be two components. Yes. So binary solution consists of two components. So if we consider the two components A and B, okay, so let Na, okay, let Na be number of moles of A, okay, let A be, Na be the number of moles of A, and let Nb be number of moles of B. Okay, so therefore, so how do you find? Just now I wrote it. So mole fraction of A equals to Na by Na plus Nb, because there are only two components. And if you want to find the mole fraction of B, it will be Nb divided by Na plus Nb. So this way you are going to find out the mole fraction. Suppose now this is for binary solution. Okay. In general, for a solution containing I number of components, we don't know how many components are present in a particular solution. Now we are considering only binary solution. As we know, in binary solution, there are only two components. Now, if we consider a solution which is containing I number means you can say we don't know. Okay, I number. So I number of components, then how we are going to and that is how we are going to write the in mathematical form. So for I number of components, then how we will write? So mole fraction of I is equals to Ni divided by N1 plus N2 plus N3, okay, plus goes up to Ni. Okay, so this is the mole fraction of ith component. So how much ever components are given, so you are going to find ratio of one component to the total number of components in the mole fraction. Is it clear now? Yes, is it clear before proceeding for the example? Is it clear? Mole fraction definition is clear, students? Yes, okay, fine. Okay, moving forward. So we'll take an example now. Okay, so if calculate, so if you are, okay, so calculate the mole fraction, calculate the mole fraction of ethylene glycol. Okay, ethylene glycol in a solution, containing, 20% of ethylene glycol by mass. Ethylene glycol by mass. Okay. What is ethylene glycol? What is ethylene glycol? Can you all tell me the formula of ethylene glycol, students? What is ethylene glycol? CH2, CH2, OH, OH. Is it ethylene glycol? Yes, yes. So this is a ethylene glycol. So that is C2. So count the number of atoms. Carbon are 2, hydrogens are 6, and oxygens are 2. Yes, Yamuna has answered it right. Good. Okay. Yes. So let me go back. Okay, fine here. So here ethylene glycol. Now what they have asked, They have asked to calculate the mole fraction of ethylene glycol in a solution which contains 20% of ethylene glycol by mass. So how do you, so first will this 20% of ethylene glycol by mass. Okay, we have seen this in the previous session, how to write the sentence. So 20% of ethylene glycol, I'll write the short form as EG by mass means what? 20% means what? 20 grams of ethylene glycol, okay, dissolved in how many grams of water? 80 grams of water. The total solution will be 100. Okay, that is 20 grams of ethylene glycol dissolved in 100 ml, 100 grams of 100 gram, that is 100 gram solution. Okay, but now we are considering what? 20 grams of ethylene glycol dissolved in 80 grams of water. Water is the solvent. So the total mass will be 100 itself. Now, so therefore, now we'll consider number of moles of glycol. So how do we calculate? So number of moles of glycol. Yes. So the number of mole of glycol will be how many? So this is 20 divided by. Now the number of, find the molecular mass. Carbon is 12. Okay, 12 into 2 plus each hydrogen is 1. So 1 into 6 plus each oxygen is 16. So 16 into 2. So find the total mass here, students. Find the total mass. Yes, find the total mass. How much it is coming? Okay, Yamuna has already told the answer itself. 62. Yes, it is 62. Okay, so after when you do the substitution and calculate, the answer comes to 0.32 mole. Okay, so because 20, this is 20 grams and your molecular weight. So whenever you are calculating the number of moles, okay, number of moles, see here, remember this one formula. So whenever you are calculating number of moles, you have to calculate given mass, okay, given mass upon molecular weight or molecular mass, you can take. Okay, or you would take it as molecular weight. Okay, so this is the formula. So number of moles, how do you calculate? Given mass was 20, and what is the molecular weight of that ethylene glycol is 62, so it comes to 0.32. Okay, next we are going to find the number of moles of what? Which is the second component? Number of moles of water. Is it? Number of moles of water. So how do you calculate? So number of moles of water is equals to given mass. What is the given mass of water? Yes, what is given mass of water? It is 80. It is 80 divided by what is the molecular mass of water? Molecular mass of water is what? H2O. So 2 into 1 plus 16, it is 18. Yes, 18. So after, so this is gram and this is gram per mole. Okay, so gram and gram get cancels. Okay, so what you get? What will be the answer? Just check. What is the number of moles of water? Yes, Yamuna has answered it right. Yes, Misbah has also answered it right. It is 4.44 moles. Okay, it is 4.44 moles. Now, next step. Yes, Suraya, Akshaya, good. Yes, Ananya has also answered. Ramya, yes. Yes, now last step. Anita, Abhilash, yes, good. Okay, so the next step is what? Now we have to find the mole fraction. So now we have found the individually the number of moles. Next step is what? We have to find out the We have to find out the mole fraction. Okay, mole fraction. So how do we calculate mole fraction now? Mole fraction of ethylene glycol is what? Number of moles of ethylene glycol divided by number of moles of ethylene glycol plus water. Okay, so this is the formula, as you all know. So calculate now. So number of moles of ethylene glycol is here. Okay, it is 0.32. And what is number of moles of ethylene glycol is 0.32 plus number of mole of water is 4.44. Yes. Answer. What is the answer? Okay, Yamuna has answered as 0.068. Yes. What about others? Everybody got the same answer? No, Suraya, no. See what you do. First, you add this 0.32 plus 4.44. Okay, first you add this and then you divide. And see, for exam, simple calculator is allowed. Okay, don't use a scientific calculator. So have a practice of using simple calculator. No, not 14.8, Ananya. It is 0.0678. The answer comes to yes. Sri Varuni has also answered it right. Good. Okay. Fine. Any doubts? Akshaya, Ramya, yes, the answer is right. Any doubts? Is the mole fraction concept clear? How do you calculate number of moles and the formula clear? Suraya has not understood. What you want me to repeat? Okay. So mole fraction of glycol. So we know how do we calculate. So of glycol will be number of mole fraction of glycol divided by number of moles of glycol plus number of moles of water. So we have found this. So number of moles of glycol was 0.32. Then number of moles of glycol 0.32 plus this is water is 4.44. So what you do? Okay, let me use a calculator. So please, if you don't have a simple calculator, please buy a simple calculator, okay? Or if you have your brothers, sisters, elder brother, sister, you can use that also. So it will be useful for you. Okay, simple calculator, not a scientific one. Scientific, if you if you take scientific calculator to exams, they'll throw you out. Okay, so don't use scientific calculator. Use simple calculator. Okay, so 0.32. So this you keep like this first, and then 0.32 plus 4.44, it comes to 4.76. Then what you have to do, 0.32 divided by 4.76. Okay, then it will come as 0.067. Yes, 72. So this will be like this. You have to simply, okay, you have to do the stepwise calculation. So we cannot tell the stepwise calculation every time. You have to follow this. Okay, fine. Uh, so shall we move forward? Okay. Next is molarity. Okay, next is what? Molarity. What is molarity? Yes, you have studied this in first year also. Now I want answers from you all. Molarity, molality, you have to explain. You have studied this in first year. I know this. Okay, Suraya has answered. Amount of substance in a certain volume of solution. Not, no, no, not proper. It is not proper. Yes, others, molarity. Nobody knows. How did you write your first year exams, students? Okay, Yamuna has answered number of moles of solute by volume of solution in liters. Okay, answers are coming. Sorry. Okay. Yamuna, moles of solute by volume of solution in liter. Okay. Then, okay, wait. Then who has answered? Abhilash has answered. Number of moles of solute present in the present, or you can say number of moles of solute dissolved in 1 liter of solution. Okay, good. Then Misbah has also answered number of moles of solute present in 1 liter of solution. Good. Suraya, okay, number of solute per liter of solution. Use their moles of solute. Okay, number of moles of solute present in 1 liter of solution. Okay, fine. This is also correct. Then number of mole of solute present in a liter. Okay, Ramya has answered. Then Anita, 1 mole of solute and 1 mole of solution. No, 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 wrong, wrong. Anita, check your answer. Then Sri Varuni, number of moles of solute dissolved in volume of solution in liter. Yes, good. Okay, yes, very good. Many of you have tried. That is main thing. Yes, Mahalakshmi has also answered. Number of moles solute present in 1 liter of solution. Good. Yes. Okay. So yes, so this is a molarity. So what is molarity? I'll give you a definition. It is defined as number of moles of solute dissolved in 1 liter of solution. What is 1 liter? Yes, Pavitra has also answered. Ananya has also answered. Okay. No. Why you answering for molarity? Wait. Let me finish molarity first. Then we'll go for molality. Okay, wait. Pause. Pause a bit. Yes. So, molarity. What is molarity? Molarity is number of solute, okay, dissolved in 1 liter of solution. 1 liter means what? 1 liter can be 1 dm cube, or it is 1000 ml, or it is 1000 ml. So, molarity is number of solute, that is number of moles of solute dissolved in 1 liter of solution, or 1 dm cube of solution, or 1000 ml of solution. Ml is the simplest way. Okay, so this is the definition, and this is a formula, that is number of moles. Okay, number of moles, that is number of moles, moles of solute dissolved, that is divided by volume of solution in liter. Okay, so this is molarity. So now, so see here itself number of moles, right? Number of moles of solute divided by volume of solution in liters. Now, if I don't know number of moles, how do I calculate number of moles? If number of moles is not given, okay, and molarity is given, and number of moles are to be calculated, then how do you find out number of moles? I had given you this formula. Please make the note, okay, whenever I'm telling you some of the important formulas, because this is, okay, this is not given separately. So when we are discussing the concept, so that time only these formulas will arise. So that time, whenever I'm telling you, please note it down. So number of moles, how is calculated? It is calculated as given mass divided by molecular weight. You can take molecular weight of that substance. Okay. Now number of moles, then how it is calculated? Given, that is mass of solute in gram, okay, divided by molar mass, that divided by volume of solution in liter. So these are the formulas. Please make a note. Please make a note of this. Very important. Okay, so number of moles is calculated as given mass upon molecular mass, you can take, or molecular weight. Then how do you calculate that is, this is the given. So number of mass of solute in grams. Okay, mass of solute in grams divided by molar mass. So this, we have expressed this here, and this is the volume of solution. Okay. So now here the volume of solution is in liter. Okay, now here the volume of solution is in liter. Now if the solution is in ml, did you note it down? Shall I erase it? Shall I clear this? Okay, fine. So here molarity. So now if the solution, okay, if the, see here, write it down. If the volume of solution is expressed in ml, okay, if it is expressed in ml, then how do you calculate? Molarity is equals to number of moles of solute, number of moles of solute divided by volume of solution in ml multiplied by, okay, I'll write here, you can't see then, into 1000 m, okay, ml per liter. Okay, 1000 ml per liter. I'll write it here. Molarity is equals to number of moles of solute divided by volume of solution in ml into 1000 ml liter per liter. Okay, so this is if the volume of solution is expressed in ml. If the volume of solution is expressed in ml, this is the formula. Okay. Now, see, there's something called a decimolar solution. Okay, what do you mean by decimolar solution? Decimolar solution. Okay, so 0.1 gram mole of solute dissolved in 1 liter of solution gives decimolar solution. Please make a note of this. Okay, 0.1 gram mole. So whenever you dissolve 0.1 gram mole, okay, of solute dissolved, when it is dissolved in 1 liter of solution, it will give you a decimolar solution. If they ask you what is decimolar solution, okay, you have to tell that 0.1 gram, whenever 0.1 gram of solute is dissolved in 1 liter of solution, then you get a decimolar solution. For example, okay, 0.25 molar, okay, 0.25 molar means it is 0.25 mole per liter, okay, solution of NaOH. So if you are having a solution of 0.25 molar, so this solution of NaOH, it contains, okay, what it contains? It contains 0.25 mole, okay, 0.25 mole of NaOH. Now 0.25 mole means what? It is approx 10 grams, okay, it is 10 grams of NaOH in 1 liter of solution. So whenever you dissolve 10 grams of NaOH in 1 liter of solution, it will give you 0.25 molar. Okay, it will give you 0.25 molar. So just have an idea. Okay, fine. Now we'll solve a problem based on molarity. Okay, we'll solve a problem based on molarity. So molarity, calculate. Now you have the formulas. Okay, you have to tell the answer. Calculate the molarity of solution. Okay, containing 5 grams of NaOH, 5 gram of NaOH in 450 ml of solution. In 450 ml of solution. Fine. Calculate the molarity of solution containing 5 grams of NaOH in 450 ml of solution. So what they have given? molarity has to be found out. Okay, molarity has to be found out. Then what? This is given. What volume of solution is given? Molarity has to be found out. Volume of solution, volume is given as, volume of solution is given as 450 ml. Okay. Then this 5 grams of NaOH. So solute weight of given weight is given. Mass of the given, this is given. Okay. That is NaOH is a solute. Its mass is given. That is 5 grams. That is given weight. Okay. Then what you have to calculate? So first you have to calculate the number of moles. We don't have number of moles, right? So how do you calculate number of moles? First we'll calculate number of moles. Okay. First I'll do stepwise here. I'll write it here itself. So first step is, see, the formula is here itself. Now moles of a solute dissolved in volume of solution. That is number of moles of NaOH is not given. So it is 5 gram given weight. Then NaOH is what? NaOH is, this is 23 plus 16 plus 1. How much it is? It comes to 40. It comes to 40. So 40 gram per mole. So calculate. 5 ones are 5 eights are. So 1 divided by 8. Okay, it comes to 0.125 mole. Gram get cancels. It will be 0.125. Yes, Yamuna has answered it right. So it is 0.125. It is 0.125. Yes, 0.125. Now we'll put the formula. Molarity is equals to, what is number of moles? Number of moles is 0.125. What is this? What is that? Volume of a given solution is 450. Now we know that if the solution is expressed in ml, what we have to do? We have to multiply it by 1000. We have to multiply it by 1000. So we'll write the units. Okay, we have to. So this is mole, this is ml, this is ml per liter. Okay, so what all will get cancelled? Just see. ML and ML will get cancelled. So multiply. So what you do? First you divide 0.125 divided by 450. It gives you 0.000277. Now this into 1000. Okay, into 1000. So if you multiply it by 1000, this comes to 0.278. Okay, 0.278 or 0.277 it will come. Okay, this should be your answer. So what is the unit? It is mole per liter. Mole per liter. Yes, many of you have answered it right. Yes, Akshaya, Navya, Ananya, Suraya, Yamuna, Nagesh, Abhilash, Ramya, Anita, Shivaruni. Yes, good. Okay, many of the answers are right. Good. So please remember the unit also. Don't forget to write the units. Units are very important here. Okay. Okay, fine. Moving forward. Next is molality. Next is, and here molarity, it is denoted by capital M. Okay, it is denoted by capital M. And molality, it is denoted by small m. It is denoted by small m. Okay, so what is molality, students? Molality is, it is defined as the number of moles of solute per kg of solvent. Yes, the number of moles of solute per kilogram of solvent. Yes, Surya, your answer is right. And many of you have already answered it before. I had seen some of the answers of Akshaya had answered. Yes, many of you have already answered about Abhilash has answered, Pavitra has answered. Okay, fine. So, yes, Anita, Ramya, Nagesh, yes, the answer is right. So, it is number of moles of solute. Number of moles of solute Okay, so molarity is what? Molality, number of moles of solute dissolved in per kg of solvent. Okay, it is per kg of solvent. That is 1 kg of solvent. Fine. Now, so molarity, the formula, as you know, number of moles of solute divided by mass of solution, that is mass of solvent. Okay, not solution. It is mass of solvent in kg. It is mass of solvent. Please make this note. That is, so molality is equals to moles of solute divided by mass of solvent in kg. So if the mass of the solvent is expressed in grams, so this is in kg. If it is expressed in grams, okay. If mass of solvent is expressed in grams, then what is the formula? Then molality is given as number of moles of solute, divided by mass of solvent in grams, okay, into 1000 gram per kg. 1000 gram per kg. Okay, got it. So this is the so if the mass of the solvent is expressed, okay, if the mass is given in terms of grams, if it is given in grams, then this is the formula. What you have to do, you have to multiply it by 1000. You have to multiply it by 1000. Fine. We'll solve a problem now. We'll solve a problem based on this. Okay, so molality. So I'll give you a problem. Okay, so let me write a problem here. Okay, so the problem is calculate the molality of 2.5 grams of ethanoic acid. Okay, there is an acid that is ethanoic acid. So you have to calculate the molality of this ethanoic acid. Okay, and that is ethanoic acid is CH3COOH. Okay, and in 75 grams of benzene, so benzene is the solvent. So molality is what? Number of moles of solute, okay, divided by what is given? Mass of solvent is given in grams. Mass of solvent is given in grams. So what we have to do? We have to multiply it by 1000 gram per kg. So put the values. So what all we have, 2.5 grams is given. That is number of moles is to be found out, right? So given mass upon molar mass. Okay. So what is given mass? Given mass is 2.5. What is molar mass? Okay, CH3COOH. So it is C2H4 and O2. So carbon is 12 into 2 plus 4 into 1 plus 16 into 2. Calculate how much it comes. It will come to, so here I have given C, molar mass. You have to multiply the, this what you have to take the atomic mass of the element. Okay, it is coming to 60. Yes. So it is, so number of moles, I'll write it here. So number of moles is given. So 2.5 grams divided by molar mass is 60 gram per mole. Okay, now calculate. Gram and gram get cancelled. So 2.5 divided by 60 it comes to 0.0416 mole. Are you getting the same? Are you getting the same? Yes. Okay. So next is what? Now you have to calculate the, put the value here. So number of moles is 0.0416. Okay. Mole. Then what is mass of the solvent is 75 grams into 1000 gram per kg. So gram and gram get cancelled. Then multiply. So 0.0416. 0.0416 divided by 75. The answer is 0.000554. Now that time only you multiply it by 1000. It comes to into 1000. Okay, it comes to 0.554 mole per kg. So this should be the answer. 0.556 mole per kg. Yes. Mahalakshmi, Sri Varuni, Yamuna, Ananya, Suraya, yes, Akshaya, all have answered. Okay, kg, not kg, it is mole per kg. Akshaya, it is mole per kg. Okay, so here, whenever you are substituting, that time only you can write the units, then you will come to know. So gram and gram is getting cancelled. We are left with only mole and per kg. Okay, fine. So this is the formula. Yes, Abhilash has also answered. Okay, so these are the concentration terms. Okay, so which we have discussed. Okay, so some extra examples on, we are going to discuss it in the last. Okay, at the last, we'll discuss some of the problems again. Okay, fine. So we'll start with solubility. I don't think we will complete everything. I'll just start with the some of the concept. Okay. So next important concept is solubility. So we have completed the concentration terms. Okay. Next important, this is solubility. Now, what is solubility? Okay. What is solubility? So solubility of a substance is its maximum amount, okay, maximum amount that can be dissolved in a specific amount of solvent at a specific temperature. Now, whenever you are dissolving, now, okay, if I have 2 kg of sugar, suppose I have 2 kg of sugar, okay, sugar is my solute, right? And I have only, what you say, 200 ml of water. I have 2 kg of sugar, okay, 2 kg of sugar, and I have 200 ml of water. So water is my what? Water is my solvent, okay, and sugar is my solute. Will it be soluble? Is it possible to mix 2 kg of sugar in only 200 ml of water? Is the solubility possible? No. Right. So what is solubility? So what is solubility? Solubility is nothing but whenever you are adding, whenever you are mixing something, okay, so that proper ratio, okay, that is whenever a substance is the maximum amount. So how much maximum amount can be dissolved? Okay, solubility of a substance is something that is how much maximum the amount can be dissolved in given amount of solvent. So in 200 ml, okay, maximum amount of sugar can be dissolved maybe half kg. Okay, may only half kg can dissolve in 200 ml. 2 kg is not possible. So this is solubility. Okay, so solubility of a substance is what? It is the maximum amount that can be dissolved in given amount of solvent at a specific temperature. So at a specific temperature only this is possible. Okay, so of a particular substance. So every particular substance, okay, it has some what solubility ratio means what the maximum, how much maximum amount it can dissolve. Okay, it is given. Now, what are the factors? What are the factors? So whenever we are adding solute plus solvent, we get a solution. Okay, and this results into a solubility factor. How much amount, how much maximum amount of solute can be dissolved in a given amount of solvent. Okay, at a specific temperature. This is your solubility. Now, what are the factors? So these are the main four factors. Please remember the factors. So it depends upon the nature of solute. Okay, it depends upon the nature of solvent. So there are some factors how the substance can get dissolved. Okay, so the first is nature of solute. How is the nature? Okay, then is the nature of solvent. Then is temperature. Okay, next is pressure. Next is what? Pressure. So these are the main factors which will affect the solubility. So these are the main factor which will affect the solubility. Okay. Now, the first we are going to see is solubility of solid in a liquid. First is what we are going to see is solubility of solid in a liquid. So, suppose when we have a solid solute. So, our solute is solid here. What is our solute? Our solute is solid. Okay. So if we have a solid solute, okay, and we are adding it into a solvent, okay, and our solvent is a liquid and a solid solute is there that we are adding into the solvent. It dissolves. What it will happen? It will dissolve. And what will happen to the concentration? The concentration, it will increase. Okay, the concentration of the solvent will increase. Okay, it will the concentration of the what you say concentration will increase in the solution, right? So when we are adding the solute, okay, to the solvent, what is happening? There will be increase in the concentration of this complete solution. What is solution? Solution is nothing but solid plus solvent, right? So what will happen? The concentration will increase. The concentration will increase in the solution. So this process, this what you say, this process is called as dissolution. What it is called as? It is called as dissolution. So remember this. So whenever we have a solid solute, okay, when we have a solid solute and we add in a water, okay, that is solvent, okay, into a solvent which is liquid state. So what will happen? It will dissolve. Okay, the solid will dissolve. And what will happen to the concentration? The concentration of the solution will increase. This process is called as dissolution. Dissolution. Okay, understood? What is dissolution? We have a solid solute, we are adding it into a solvent. What will happen to the concentration? The solid will what is that? The solute will get dissolved. Okay, and what will happen to the concentration of the solution? It will increase. This process is called as what? This process is called as dissolution. Dissolution. Okay, now at the same time, okay, at the same time, what will happen? The solute particles will collide with each other. What will happen? Whatever the solute particles are there, they will collide with each other and they will get precipitated out. Okay, and they will get precipitated out of the solution. And this process is called as that is crystallization. This process is called as what? Crystallization. So we are discussing two important factors here. First is dissolution, another is crystallization. Another is what? Crystallization. Okay, what is crystallization? That is at the same time. Okay, at the same time, what will happen? The solute particles will collide with each other. Whatever the solute particles are dissolved, they will collide with each other and they will get precipitated out. They get precipitated out of the solution, and this is called as crystallization. This is called as what? Crystallization. Okay. Now, after some time, now what will happen? So we have seen now two the processes going on. Okay, so what is happening here? So first we have seen dissolution. Okay, understanding the terms. Yes, don't get confused. So dissolution, then we have seen crystallization. Okay, next we have seen crystallization. So after some time, now after it has got precipitated out, okay, after it got precipitated out, then after some time, what will happen? The concentration of solute will increase. The concentration of solute will increase and a stage is reached. Okay, a stage will be reached where dissolution and crystallization occurs at the same rate. Okay, so a stage will reach where dissolution and crystallization will occur at the same rate. That is, the solute particles going into the solution will be equal to the solute particles crystallizing out. Okay, and a dynamic equilibrium is reached. Okay, a dynamic equilibrium is reached. So that is your solute plus solvent. Okay, solute plus solvent will give you solution. So a equilibrium will reach. So what is happening here? So such a solution in which number of mole solute particles can be dissolved at a specific temperature is called as saturated solution. So this is called as saturated solution. Okay. So when the number of moles of solute particles, okay, how much number of particles is dissolved, okay, then it is called as the saturated solution. There is something called as unsaturated solution also. What is unsaturated solution? If the concentration of solute particles in the solution can increase at a given set of temperature and pressure, then it is called as unsaturated solution. Okay. Now, these are some of the important terms which we are going to use in solubility. So, if it contains maximum amount of solute, okay, dissolved in a given amount of solvent, then the concentration of solute in saturated solution is called as its solubility. Okay, so this is something called as solubility. Okay, is it clear? I think a bit of confusion will be there. Okay, but at least you have understood what is dissolution up to dissolution. I hope up to dissolution is clear. Yes. The crystallization and the other parts, dynamic equilibrium, how it is reached. Okay, saturated solution, unsaturated solution. So that I'll discuss it one more time. Okay, so yes, I think the time is up now. So the remaining things, okay, so up to dissolution, I think, so what is solubility? What are the factors that are affecting? Okay, then we have discussed how the solubility of solid in liquid happens, that is the dissolution. Okay, so up to dissolution, it is clear. Okay, the remaining things we will discuss in the next class. Okay, so the remaining things we shall discuss in the next class. Any doubts? If you have any doubts regarding today's session, you can ask me. Okay, no doubts. Fine. So I hope whatever the things have been told today is understood. Okay, fine. So I shall end this session here. Okay, so we'll meet in the next class. Thank you.